Hi, my name is John. Welcome to part 8 in a series of short videos all about the metal turning lathe. In this episode, or this installment, I'm going to carry on from the last one and discuss and demonstrate work holding. Before I move away from the 3-jaw chuck, as quite a few people have asked us to demonstrate one, it's not a unique feature, but one feature that I did build into the chuck when I installed it onto the back plate. So that's enough talking. I'll bring the camera in, we'll discuss this one more thing on the 3-jaw chuck, then we'll move on. This 3-jaw chuck probably does 75% of the work I do on this lathe. It's a self-centering 3-jaw chuck, as we discussed last week. I'm going to put a piece of bar in that I know is perfectly straight and perfectly round. The chuck's got 3 tightening points. One of them has got a 0 on. That's the tightening point that was used to tighten the chuck when the jaws were ground. So that's the one you use to tighten last. It gives it the best chance of being accurate. If you look at it, it looks fairly true. I've just had the chuck off and put it back on, and when I take the chuck off and put it back on, it never seems to go back perfectly true. It's normally within 2 or 3 thou. I'm going to put a clock gauge on and just check the run out. The further away you are from the chuck, the more accurate your reading will be. Right, and that's running out 7 thou, which is not acceptable as far as I'm concerned. Now, when I did the chuck and the back plate, I left clearance between the chuck and the back plate on the spigot it mounts on. So all I need to do is loosen off these 3 cap head bolts. And I can bump the chuck into line. So we'll find the high jaw first, which is that one there at a high point. Again. Again. Right, and that's now running within half a thou. I'll try and get it absolutely dead on. Right. That's about as good as it gets. I'll bring the camera in so you can see a little bit closer. As you can see, that's virtually 0 run out. So now, no matter what I put in this chuck, within its range, it's within 3 or 4 thou, which is very, very acceptable for the 3-jaw chuck. The natural progression from the 3-jaw self-centering chuck is a 4-jaw independent chuck. I've got 2 of them, a big one and not quite a big one. I'm going to use a big one, it's just easier to video, easier to demonstrate on. So we'll take this one away and I'll mount the 4-jaw chuck onto the lathe. 4-jaw independent chucks are normally found in a cupboard under the lathe, covered in rust, unloved, which is a great shame because it's the most useful work holding bit of kit you can have on a lathe. Obviously by 4-jaw we mean it's got 4 jaws, and by independent it means that each jaw moves independently. So you can move that one, you can move that one, all independently. You can also take a jaw out, or take all 4 jaws out, turn it over, put it back in that way, depending on what you're trying to grip. So 4-jaw chucks don't just grip square material, they'll grip any shape basically. If you have to put something in a chuck and have it running dead true, a 4-jaw chuck is probably the way to do it, because you can adjust these to take out any tolerance at all. You can adjust them to get them absolutely spot on, no matter what shape, size or diameter the workpiece is. On the face of the chuck there's a series of rings. They're not there to make it look pretty, they're there to try and help you set up the chuck. I'm going to grip something round, so what I've done, I've estimated the size of the piece. That's the piece of round bar there. You could measure it, but I reckon probably 3 inches. So I've set the gap there roughly 3 inches, and what I've done, I've lined up each jaw on that outer ring. So we'll try the piece in. It won't go in, the chuck is too tight. So if we open each one half a turn, now it fits in. It's slack but it fits in. So if we nip up each jaw, probably quarter of a turn or just until it just touches. Right, spin the part and it's reasonably true. This piece of bar will not be completely round, but it won't be far away. So straight away we've got that within the realms of possibility. I'm going to put a clock gauge on now and so far away it actually is. If we rotate the chuck, it's running out probably 70 thousandths of an inch. So what we do, we find the highest jaw, that's the highest point towards the clock gauge, and it wants to go across that way. So if we loosen off the opposite one just a little bit, tighten that one, straight away we've improved it. So it's high jaw again, which is that one. So loosen off that one slightly, tighten that one. There is a method of doing this using 2 chuck keys. I've done a video, I might well include it on the end of this one. Right now we're within about 10th out, so we'll find a high point. You could zero the clock gauge if you wanted to, if it would move. Right, we'll not zero it. Right, so once again, high point, which is that one there. So now we'll just try nipping that one and push it against the other one. And use a slightly bigger chuck key with slightly more leverage. High point again, which is that one. Just keep working on it, and slowly but surely the run out is removed. I'm going to have to loosen off the opposite one a little bit. And we're getting there now. It's within 2 thou and the bar won't be round, so we'll find the high point again, which is that one. That's as good as it's going to get, because that bar is probably that far out of truth anyway. Right, so that's within. It's probably dead on, but like I say, the bar's not round, it's within 1.5 thou, 2 thou. Right, so for gripping round stuff, here's a bit of aluminium bar, and there's a centre drill mark there. I need to drill a hole through there, and I haven't got a drilling machine, and it's got to be accurate. We can do it in the lathe using a 4-jaw chuck. We can do it in the lathe using a faceplate as well, but 4-jaw chuck is what we're demonstrating in a minute, so that's what we're going to be using. Right, I reverse these 2 jaws, take them out, turn them round, put them back in again. And if I put the piece of metal in there, it means that the centre hole is somewhere near. You could nip this up and then mess around trying to line it up, but there's a much easier and quicker way of doing that. What we need is a decent centre in the tailstock chuck, which we can bring in and line up on that hole, on that centre mark. You need to come towards me a little bit. Go across that way a little bit. This is easier with 3 arms, but being as well I'm just human. Right, so if we wind that into there, that holds it in place, so we're not juggling trying to fight it. So it's got a little grip on there, and that's got that lined up dead on in the centre. So if we bring these jaws down, better. Right, push it in again. We bring these jaws down to just touching that piece of metal like that. And the other two jaws come in until they're just touching it. Basically, it's going to be not a million miles away from centre. So it's lying on the back of those two jaws, and those two jaws are just nipping it in. Right, so we need to get the whole spot on. We know we're somewhere near. Right, what I've now got is a dead centre in there. That's been held in by the grip of the jaws, and all that's doing is acting as an indicator to see where the hole is. So if we put a clock gauge onto there, and that's within 25 thousandths of an inch. So all we're doing now is find the high point, which is nearest to me, which is that one there. We'll nip that jaw up a little bit. High point again, which is that one still. High point, which is still that one. I'm going to put a little nip on these side ones just to make sure I have got it. Right, once again, high point, which is now this one's moved. High point is that one. It's within a thousandth of an inch there, so it's getting... Right, so that is not bad at all. There's a couple of things you've got to be aware of. The first thing is this jaw could hit the lathe bed, and the second thing is it's not balanced. It's a mile out of balance because you've got all of this weight sticking out that side, so obviously you couldn't set this away at 1000 RPM. It would move the lathe across the workshop. But to drill a hole in there, it will comfortably run at 20 or 30 RPM, so you can drill the hole. If this was a finished piece of work, you'd put copper jaw protectors in there just to stop damaging the workpiece. So you could drill the hole, you could face that as well, all on the one setting. So that's a job that will be done normally on a milling machine, can be quite happily done in a 4-jaw chuck. I hope you found that short video interesting. I hope you managed to learn something from it. So don't forget, have a look in the cupboard. If you've got a 4-jaw chuck, take it out and play with it. It is a very useful piece of equipment. I did a video quite a few years ago now. I think it was called 4-jaw fun. I'm going to put that up again. I'll relist it. That shows how to set up a 4-jaw chuck using 2 keys and a clock gauge. I'm sure you'll find that interesting as well. Anyway, thanks for watching.